Hello everybody, welcome to my course Reactive Intermediates, Carbenes and Nitrines. So far we have learned various aspects of carbenes. Now we are studying among the different reactions that is associated with carbenes. So far what we have learned that among the carbene reactions, first we have learned the addition reactions. Okay. So, what we have learned over there, if there is some kind of olefin or alkyne, then this will give some cyclopropane ring. Okay. Next we have learned about insertion reactions. Okay. What does it mean? That if there is some carbenes is there and there is some, as for example, some carbon hydrogen bonds is there, this carbene can be inserted into that carbon hydrogen bond. As for example, so this can give okay. So, another type of reactions also we have learned in the last class, that is the nucleophilic attack of various nucleophiles towards the carbene. As per example, if you have RXH that can react with the corresponding carbene to give the nucleophilic attacked product. Okay. So, now next what today we will learn another type of reaction, that is called rearrangement reactions. Okay. Okay. So, if we see that if there are certain substrates with no beta hydrogens, I mean the carbenes that is generated, there is no beta hydrogens. So, there are various type of reactions are possible. As for example, there are CH insertion reactions are possible, as well as there the rearrangement reactions also possible. So, if we have this carbene with no beta hydrogen, then there is high possibility of CH insertion. Okay. Additionally, this can proceed with rearrangement reaction. Okay. If we take this substrate where there is no beta hydrogen, now in presence of Schlosser's, one of the Schlosser's base, we know previously that it will generate the carbene moiety through this way. and then the chloride liberation, and then this will give the corresponding carbene. Now, if we see this carbene, there are several things possible. As per example, there are the CH insertions, that is possible to give some kind of cyclopropanation. Okay. Or there are now two possibility for rearrangement. One is that this methyl can migrate and this phenyl group can migrate, okay, to give the rearranged product. So, what it will form? It will form actually that once this will come, then either this one can migrate, okay, or if this one migrate, then another product will form. Okay. So, now if this one migrates, then what will happen? What will be the product? Then if this phenyl migrates, then the product will be this. And what has been found? This is in 66% yield. That means, this is the major product. Whereas, if this methyl that can migrate, then obviously what will form? Okay. So, in this case what has been found? This is very minor amount, this is also minor, whereas this one is the major product. Now, question is why it is happening? Okay. So, now why this one is forming as a major product? If we see the migrating aptitude, the phenyl ring is having more migrating aptitude than the methyl group or alkyl group. That is why here this migration of this phenyl is more. Next, we will see another similar type of example, that is here the precursor is the corresponding diazo compound. Okay. Now, under thermal condition, okay, so this will give the corresponding carbene. Now, once this carbene is there, again there is two possibilities or rather three possibilities, that first the cyclopropanation can happen as there is no beta hydrogen. So, the cyclopropanation can possible, or there are two groups, two rings that is there, sorry, two groups are there like methyl or phenyl, they can migrate to give the rearranged product. Let us see what will happen. So, what has been actually found, that there is actually these product formed in 41%, that is the cyclopropanation one, where this insertion happened, whereas there are other two products formed by this rearrangement, that is the coming of this group or this group, whatever it may be. Okay. So, if this migrates, then the following product will be but this is only 9%, whereas the major product, that is after the phenyl migration, and that is this product, and the yield is 50%. So, if you see that where there are different type of reactions are possible in this type of particular substrates where this beta hydrogen is absent, and actually it gives the mixture of products, and in that case we are getting the, as we expected, that cyclopropanation happened and there is possibility of migration, and as there are two different type of groups which can migrate through this for this rearrangement. So, it is actually possible to see that these two groups actually migrating, and in one case if the phenyl group's migrating aptitude is higher than the methyl group, that is why phenyl group is migrating and giving the more amount of product, whereas when the methyl group is migrating, the amount of product is less because of their difference in the migrating aptitude. Okay. In another type of substrates where again the diazo compounds are the precursor of the carbenes. So, this is a corresponding bicyclo octyl diazomethane type of compound. Okay. This is having the bridge head, and now this is the substrate. Under photolysis, this can give the corresponding carbene. Okay. Now, once this carbene generated, again I am now considering on the major product. So, okay, then this bond can migrate over here, okay, or we can draw in this way. Okay. So, once this will do this migration, then actually the expansion of ring will happen. So, here it is 6 member ring. So, once this rearrangement happens, then we can make it more clear or more visible here in this way. Okay. So, if this happens, the due to this rearrangement, the this ring 6 member ring becomes the 7 member ring. So, what will be the product? Here the product will be okay. So, number of rings, if we see that 1, 2, 3, 4, 5, 6, 7. So, this becomes the 7 member ring. So, we have started from 6 member ring, okay, having this bridge head, and that we arrive at 7 member ring. Again this is due to this particular rearrangement. Okay. Now, where the carbene that is generated by this under basic medium or under heating condition by any means, if there is a double bond adjacent to the carbene, then what will happen? We will see that example. As per example, here if we take this carbene which is adjacent to this okay. So, now this is the this is the carbene precursor, which under basic, medium and heating condition, that will generate the carbene. Okay. So, if we start from this N-tosyl hydrazone, and from there if we treat with under basic conditions and heating condition, then that will generate the carbene that actually adjacent to a olefin. Now, once we have this olefin, now it is ready for this rearrangement, and that actually can give this cyclopropene derivative rather. So, what we will get here, the product that will be okay. So, this is the corresponding cyclopropene derivative. Okay. So, we are starting from the N-tosyl hydrazone derivative, and or not only N-tosyl, this type of it could be air. So, if we treat it with base followed by heating, then we will generate this carbene, and once this carbene will generated, then that can go for this rearrangement to give the cyclopropene derivative. Okay. Next we will see that if we will generate different type of cyclopropylidines, then how that can rearrange to another class of products, that is called allenes. As per example, if we take this substrate which is having this cyclopropane ring, so N-nitrosourea type of derivative if we take, then this N-nitrosourea type of derivative if we take and treat with some base, then again this will generate, we have seen that different procedure how we can generate the carbene. Okay. There also we have seen that how this N-nitrosourea derivative can generate or form the carbene. So, these are the things that are very good precursor for the carbene. So, here also we have taken the similar type of substrates, where this substrate, this N-nitrosourea can be treated with base to form the corresponding carbene. As per example, here we have generated this carbene. Now, this carbene is ready for the corresponding rearrangement. So, again we can do this, and this one can come like this. So, if we see that this particular cyclopropane ring now opened and give the corresponding allene moiety. You know what is allene? In case of allene, these two groups and these two groups, they will be perpendicular. Okay. So, they will not be in a same plane. So, that is why they are written in this way. So, this is a special type of compound, this is called allene. Okay. In another example of making such kind of allenes, where we have not taken that as a carbene precursor, we have not taken this N nitrosourea, rather we have taken this dichloro substrate. Okay, this cyclopropane with this dichloro, and now if we treat with N butyl lithium, then again we, as per our previous experience, we know that it will give the corresponding carbene. Okay. Now, this is ready for the rearrangement, and once it will rearrange, then it will give the desired allyne type product, and here it will be this allyne. Okay. So, once we are taking this cyclopropane derivative, which can generated this carbenes, that is the cyclopropylidines rather. So, that will goes via this rearrangement to provide this allyne substrate. Okay. Question is that if we now take another similar type of compound, where this not we are taking the 3 membered cyclopropane ring, rather we have taken the 4 member ring. Let us see how it will work. So, we have taken this bicyclic compound, where this 6 member cyclohexane ring is fused with cyclobutanone, and they have the cis ring junction. Okay. So, this is the substrate. Now, we know that this substrate, if we now treat with the corresponding diazomethane, then what will happen? Okay. So, now this can nicely react with this, okay, because of having these 2 chloro group, they are having this minus I effect, that made this carbonyl group is more electrophilic. This carbonyl center becomes more delta positive. Okay. So, this place becomes more electrophilic. So, the diazomethane can react over there, and to give us this product, sorry, this intermediate, that is okay. Now, once it is there, then this can nicely migrate over this for the nitrogen elimination. And if you see carefully, you can understand that here 4 member ring can be expanded to 5 member ring, right. So, okay. So, now once this bond, this one migrated to this particular carbon, then if we see this is this carbon, what is here. So, now it is here. Okay. So, then the carbonyl group, because this bond is breaking, right, and here that is making the new bond with this particular carbon, and giving the corresponding 6,5 fused ring with dichloro. Okay. Now, this dichloro that can be in presence of zinc can give the saturation of this ring to a okay. In presence of zinc, this compound becomes the saturated ring, and with the reduction happens, and then that gives this corresponding 6,5 fused compound. Okay. So, these are different type of rearrangement reactions that we have discussed now. Okay. Thank you.